Okay, how are you all today? Good. So this is the plan. We're going to do the test corrections, finish those up, and then we'll hit questions on 27 and 28, probably get through those. 29 I didn't get to, so that we'll finish on Monday. The fun sheet, as you can see, yeah, I'm not a big fan of the worksheet. Who wants to do a worksheet? That's such a negative connotation. This is a fun sheet.
Oh, yeah.
So much better.
Changes it, really?
Got me out.
Okay, so you'll love this fun sheet, as the name would indicate. It's kind of a deeper level of stuff we've done this week. It's AP kind of questions slash college textbook approach to some of these problems. Some of it's pretty straightforward. Some of it requires a little bit of thought. I'll just say this, throughout the course of the year, there are going to be some tough questions that cause you to wrestle with an idea, and that's good practice. Okay, that's how you're going to succeed on the AP test, because no matter how good a job I do, on the AP test, there's going to be a curveball where you're looking at it and going, I've never seen this before. That will happen if you practice what to do in that situation. What do I do if it doesn't look familiar? How do I make a connection to something I know? Because it's not like it's unrelated completely. It's got to connect to something you know. You've got to practice that skill. How do I connect it to something I know? And you'll do that by, over the course of the year, when you get a stumper, giving it a good go. Not succeeding necessarily, just giving it a good go. All right? So that's what I'm asking. Give it your best thought. Try and make a connection. And that's just great college level thinking you're going to do there. So now the test. Let me pause this and then we'll hand you back your. Okay. The answers that you need answers for, then I'll hit the questions. On the front, you should be pretty good. On the back, 21. Did you say yes, it was continuous, or no?
No.
No, and how did you show that? Okay, so the limit as x approaches -2 from the left, which would be of x plus 1, approaches -1. And the limit as x approaches -2 from the right, which would be -2 cosine of x plus 2, which is cosine of 0, and cosine of 0 is 1, -2 times 1 is -2. Those are not equal. So something like that, yeah? Okay, for 5, 6, and 7, actually it would be box 26, I suppose. Although their numbers 5, 6, and 7. Box 26, the first one, 5, what did you get? The limit as cosine of -1, which is 0. What do you get the cosine of 0 is? 1. Did you get 1?
Oh, no.
Do we agree or disagree?
Agree.
-1? I disagree. I say 1. Okay, because the curve goes to 0, cosine of 0 is 1. 6, as x goes to 2 from the negative side, from below, the y values approach 2. 7, 2 from the positive side, the y values approach 4. And 11, x f of x. Well, x is going to approach 5. What does f approach as x approaches 5? From the positive side, I think that says 2. So 5 times 2 then is 10. All right. My answer for the tangent line problems that. Oh, I didn't see that. Oh, good call. 10. Arctangent of 5 from the negative side. As you approach 5 from the negative side, the y's approach 1, and arctangent of 1 is I over 4. Okay, again, as you trace along the curve towards 5, the y values approach 1. Arctangent of 1 is at what angle does tangent come out to be 1, and that's at pi over 4. Okay? Tangent line, it goes to what you used for your point, but what's closest to 46 in terms of a square root? 49. So my tangent line was y minus 7 equals 1/14 x minus 49. for my estimate then, my estimate at root 46 is putting 46 into that. I have 6 and 11/14. For the other tangent line, I'll be happy to go over this. I'll just give you answers. I'll go over the questions. If you have questions, I'm happy to. Okay, the point closest to e to the 0.4 I used was 0, 1. The tangent line, therefore, is y minus 1, 1, x minus 0. And so the estimate is that e to the 0.4 is approximately 1.4 was my estimate. All right, so here we go. Questions on set 27, number 1. Is number 1 still a question, or did you have an epiphany? Number 1 is still a question. Oh, okay. Yeah. Let's start here. They tell you that the amount at year 1 is 1.53 million. I'm just going to use in millions. And the amount at 3 years is 3 million, yeah? All right. We know the exponential relationship is this one. And so there are two schools of thought here. There's one school of thought that says you really do have to go back and find the original amount. That's a lot of work, so I'm not of that school of thought. I'm of the let's do as little work as possible school of thought. So I'm going to refer to this, or think of this as my starting amount. And I'll deal with the fact that it's not really a starting amount in a second. But I'll call this 1.53. This then would be 3 million, and e to the k. Now that t then really represents the time from one case to the other, so that would be 2. So the k is natural log of 3 over natural log of, no, that's not true. Natural log of 3 over 1.53, yes? All divided by 2. There's my k. Are we tracking? Now, in terms of an equation for the amount at any given time, I'm going to, again, keep using 1.53 as my starting point. And I'm going to play with the time a little bit. E to the, I have my k, it's that thing. You actually don't even have to write it again because it's been identified. If you wanted to write it as k, I'm fine with that. But let's talk time. I can't just call it t, because t is supposed to be time since the inception, right? If I'm not mistaken. T is the number of years since the company started. All right, so if I put 0 in there, it all kind of falls apart, because then I'd get 1.53 as the starting amount. So how can I play with that t to make it all work? T minus 1, yeah. Now let's check that. If at time 1, I put in 1, wouldn't this then go away and I'd be left with 1.53 million? And so it seems fine. It's like a shift. We shifted the graph right to 1. All right? So that's a good equation. And then the value of the years after 7 years. 7 years after this number started would be just straight up putting a 7 in and cha-cha-cha. If you follow me with the cha-cha-cha. Who doesn't like to cha-cha-cha? Huh? All right. Is that, hold on a minute or move along? Yeah, that was an or statement. That was an or question. Why do you say yeah? We're good or move along? Yeah.
Yeah.
5. I'll put 5 over there. 5. Did I change this in any way? Or
Alternate definition.
alternate definition. So you're getting you started.
And then,
Not 5. Anybody need 5?
yes.
Yes. Okay. So the alternate definition is this. It's used to find slope at a point. In this case, the function is same, in which case it was negative 1 over x. And they say, I set at x equal 5. So the setup would be c approaches 5, or sorry, c is 5, so x will approach 5. F at x is what it is, negative 1 over x. F at c is f at 5, which is negative 1 over 5, x minus 5. You with me? Now the intention is that you do this in algebraic fashion, not the power rule. They're using the definition of the derivative, so you should do it in an algebraic way. The limit as x goes to 5, you have negative 1 over x plus 1/5. Like every derivative definition, you get 0 over 0 if you try to direct substitute. So the algebra I did was common denominator. Common denominator in the numerator is 5x, making the numerator of the numerator negative 5 plus x over x minus 5. Do you see where I'm coming from? Well then, if you're dividing by this, you could divide by the reciprocal. Negative 5 plus x and x minus 5 are the same, and so if you then drop that factor, you're allowed to direct substitute, and you'll get it. All right, 12. Is 12 still a question? 12 is a yes. Is 12 changed in any way, or is it straight up? Straight up. All right. Key trig identities to give. Okay, this is actually has a point. It's not just to make your life miserable and make you think back to your pre-calculus days. There's a calculus point to this. You're supposed to write this as a function of cosine 2 theta. The reason you do that is because it's a heck of a lot easier to integrate cosine of 2 theta than it is cosine squared of theta, and that's why you make that switch. Let's go with this. I don't know if this is what they want, but I'm going to say this. Cosine of A plus B. Do you remember it? In shorthand notation? Cosine A, cosine B, plus or minus? Minus sine A, sine B. And I'm going to use a little shorthand notation just to get there, all right? Now, if they want 2 theta, that implies instead of 2 different angles, A and B, I'm going to use the same angles, like A and A. So if I use the same idea for A and A, then it'd be cosine A minus sine A, sine A. Or in other words, cosine of 2A equals cosine squared of A minus sine squared of A. Now status check, we're almost there. You're supposed to write this, what are you supposed to do? As a function of cosine 2 theta. All right. It says right, cosine squared is a function of cosine 2 theta, nothing else. Well, I've got the cosine squared, cool. I've got the cosine 2a, cool. This is a problem. What can I do about that problem? Dump it. What can I replace it with? Yeah, 1 minus cosine squared a, which implies cosine of 2a is 2 cosine squared of a minus 1. Now we're ready to finish. It said to write cosine squared in terms of cosine 2 theta stuff. So that would imply that cosine squared of a, or theta, is cosine of 2 theta plus 1 all divided by 2. All right, and then you can integrate that if you want. 15. Is 15 still a question? Okay, this actually, although it's long, it's worth doing because this really deepens, if you get into it, it deepens your understanding of the derivative. So the question asks you to take the sine curve, start with one solid defined point on it. Let this be 1 point, pi over 2, 1. And they want you to then find the slope between that and any other point on the curve, like x, y. All right? Now, the first part, part A, then, is the slope between those points. Slope is change in y over change in x. Change in y is y minus 1 over x minus pi over 2. But they say for the slope, make it in terms of x only. So what can you put in y's place? Sine of x minus 1 over x minus pi over 2. That was part A, make a slope function. There it is. Now, where they're headed then is to say, all right, now graph the slope function between those 2 points and start looking at what happens as x gets closer and closer to pi over 2. Well, that would mean the slopes look like this, and this, and then 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 this, and they start to get closer and closer to 0. In the interest of time, I'll just say what this looks like here. This is the slope. Keep in mind, you're not supposed to see the sine curve. This is, they didn't say graph sine. Okay. If you graph the slopes between pi over 2 and some other point, then the slopes look like this kind of funky curve. They said, what happens in the slopes as x approaches pi over 2? And you can see that as you get closer and closer to pi over 2, the slopes start to get smaller and smaller and smaller. The slopes start to be 0. And when I say slopes, I mean really the y value or the result of this slope calculation starts to get closer to 0. That makes sense. As this point gets closer and closer, that slope starts to flatten out. And so it makes sense that the slope is 0. So part B was in the calculator. I did that for you because I'm a sweetheart. Part C was approximate the slope. It looks like by the calculator the slope starts to approach 0. Part D then is say, okay, well, how does that mesh with calculus? What is the derivative of sine at pi over 2? Theoretically or analytically, we just say, well, that's the derivative of sine, which is cosine at pi over 2, which is 0. That seems to match. The slopes approach 0, and the derivative is 0. So that the slope equals the derivative is very logical. That's the intention. You get a visual. Answer me this. As x goes to infinity, the slope would approach. As x goes to infinity, the slope would approach what? Now, I see what you're saying. It wouldn't approach anything because the curve does go back and forth. But if you think about us, let me draw this on a little smaller scale. If I take this point and this point, this point, this point, this point, this point, what do those slopes approach? Yeah, they approach 0. Yeah, even though there's this back and forth, the other point gets so far out that it starts to approach 0. It goes flat down. Okay? All right, that's kind of a fun question we talked about. 22, question on 22. Is that still a question? Yes, no?
Yes.
You don't remember your old synthetic division?
I never.
You never, I never knew it to begin with. All righty then, 22. So check this out. Let's look at this here idea just to remind you of the point. 3x plus 1 equals 0. Say I solve that quadratic by factoring. And it factors this way. The solutions, therefore, are negative 1 over 2 and negative 1. This solution, if we trace back to where solutions come from, the genesis of these solutions, this 1 comes directly from this one, which came from that guy's factors. So it feels like the top of solutions come from the factors of the last number. And this 2, it came from this, which came from this. And so it seems like solutions also have to do with the factors of the first number. That's the rational roots theorem. Possible solutions are factors of the last over factors of the first. So in this case, if x squared minus 2x squared minus 5x x cubed minus 2x squared minus 5x plus 6 is to be found, the candidates are factors of the last over factors of the first. Because the first is 1, these will be nice. The only possibilities are plus or minus 1, 2, 3, and 6. Do you see where I'm coming from? I'm trying to teach pre-calculus in about 1 minute. Okay, so those are the things I'll try. Now, if you remember your synthetic division, then that's preferable. But if you don't, then you can always say, let me try 1 by just plugging in 1. 1 minus 2 minus 5 plus 6 is 0. 1 works, okay? The reason synthetic division is superior is because if you try 1 and you see it works, then where do you go? It doesn't really take you anywhere besides knowing 1 works. Synthetic division takes you somewhere because if I try 1, and remember, it's bring down the first number, multiply, recorded here. Add, multiply, recorded here. Add, multiply, recorded here. Now here's why synthetic's so awesome. Yes, you just found that x minus 1 was a factor, but it also, this quotient, that's your quotient there, tells you that when you factor out x minus 1, what's left is x squared minus x minus 6. And now you have this quadratic to work with, which you can use your factoring skills, x minus 3, x plus 2, and you see that the roots are 1, 3, negative 2. You with me?
Yeah.
Cool. Or not? Move on? Or good? We're good. 23. Question on 23?
Yep. I didn't know about it.
Yeah, this is actually a really good question. So you have a quadratic. Quadratic is code for parabola, yeah? So an x squared equation. The x-intercepts, or the roots, are 1 and negative 2. That usually then leads you to say, I'm going to use factored form if they give me roots. The problem then is the y-intercept. They also say the y-intercept, by the way, has to be negative 4. Now, the temptation then is to say, all right, I make the y-intercept by slapping that number at the back. The y-intercept is just the constant that's hanging off here. And so the y-intercept is negative 4. Boom! Done, yeah? Good or bad? Bad. You just ruined everything. Okay, now, this was good. Does it have the correct x-intercepts? Yes, okay. What did you just do by virtue of doing that? You just screwed up you just shifted the graph. Oops, sorry, I should be doing this. You just shifted the graph down 4. Now, you just ruined your roots, but furthermore, is your y-intercept really negative 4? No, your y-intercept is actually negative 6. So you screwed up your roots and you didn't get it. That then is not how you achieve the y-intercept. It's not by adding a shift. It's by adding a stretch. I have these roots, but I need to stretch it so it passes through down lower. And you do that by virtue of a coefficient. That's how that's going to be achieved. If you put in the point 0, negative 4, then by doing so, it takes it from 3 unknowns down to 1 unknown. Negative 4 equals a times 0 minus 1 times 0 plus 2. Negative 4 is a times negative 2, so a is 2. And you stretched it in a way that gets those roots. It doesn't lose those x-intercepts. You follow? 23, check. 24. Man. 24. Did I replace 24? Well, they tell you how to do it, for Pete's sake. Do you not read math?
No, I read it, and then I got -6 over a minus 6. I don't think that was the answer.
The product of the length of the secant and its external segment times the length of the secant. All right, so think of it, I'm going to put this in layman's terms. Outside times the whole equals outside times the whole. So A x 6 x minus 1. Outside times the whole equals outside times the whole. For this one, what's the outside?
Oh,
X, and the whole is a plus x. And this outside and the whole x minus 1 plus 6, so x is plus 5. That keeps
if
going.
it says secant, is that like the
The whole.
Okay. I was thinking just like the whole thing.
Yeah, that would make sense, but no, I know it's the whole. 25. 25. Is 25 a yes? Actually, I like 25 because I have a fun way of doing this that you maybe thought of, maybe not. Surely to answer this question, it would be good to know what x and y are, yeah? So you could solve this by substitution. X equals 4 plus y, and solve it by substitution. Okay, that's not fun. Let's do it this way. To get x squared plus y squared, what could I do to x minus y equal 4? How can I get some squares for them? I could square both sides. X squared, what is this square? X squared minus 2xy plus... Now I'm going to rearrange. Here's the x squared plus y squared I want. Boom, that's what I'm looking for. What about xy?
Good morning, Devlin Jaguar. Please rise for the Pledge of Allegiance.
Boom.
Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, so 22.
Justin will be here during the lunch.
Tangelines, do we still need more of those? One vote.
Yeah.
If you go back to
Stop by a counseling office to verify and sign your next to your legal name as it should appear on your diploma.
Meeting for boys mentors is today. If you were not a mentor last year, you must come. I know counseling is E100. If you have a conflict, name is your door.
Are you interested in global issues, diplomacy, international relations? Would you be interested in being part of the first model UN team at Delaware? Please call us in room W205 for more information.
Now it's a caller from Galesburg, Illinois, and Johns Hopkins University from Baltimore, Maryland. Will be in the Counseling Center on Monday, September 11th during 7th hour. Listen to what these amazing colleges have to share. Sign up using Naviance and use the 7th hour app for counseling.
Arizona State University will be hosting an Explore ASU event on September 21st at 7 p.m. at Montiana in the Denver Tech Center. Counseling has the details to RSVP.
September 20th at 7:30 p.m., Duke University will present Information Night at Lakewood High School. Pre-registration details and counseling.
Boston University is hosting reception for juniors and seniors at the Hyatt Regency Denver Tech Center on Sunday, October 1st at 7 p.m.
Swing Dance Club meets today. Sign up at the small gym. Beginners welcome and encouraged.
Frogs Club is a student-led Bible study meeting in Miss LeBonc's room E112 today. New attendees are welcome.
Are you looking for a fun way to get more involved in high school or enjoy volunteering? Join Interact Club. Pick up an application form from Mrs. McSimmon's room and turn it in by Wednesday, September 13th. First meeting is Friday, September 15th in the library.
Girls Learning is meeting today in the classroom. Recheck the board outside the cafeteria for your room assignments.
Senior high students. Seniors, it's that time of the year again. You must have all senior pictures and photos turned in by today. Senior baby pictures cost $50 and are also due. Email them to yearbook.jags@gmail.com or bring them to Mr. Jacobson's room, L200C in the library. Don't miss out on this fun senior tradition.
All high school students, come join the new Spanish Club today for its first meeting in Miss Stevenson's room. The Bingo and candy prizes will be played.
Fellowship of Christian Athletes will be meeting in Mr. Falcone's room, W206, for 7th hour today. We will meet there and then go outside for games. See you there.
Junior high students, hey you 7th and 8th graders, yeah you square root of 169 and square root of 196.
For the last one, try using 0, 1 and it'll go better.
In the Qstns room, 7th hour on Friday. Be there or be